Long before cities were built, the first shelters were responses to the environments people inhabited. Branches became frames, leaves became roofs, animal skins became walls, stone became structure. The materials were immediate, local, and biological. A shelter could be dismantled as quickly as it was assembled. For most of human history, the distinction between the built environment and the living environment was therefore far less pronounced than it is today. People settled beside forests, rivers, grasslands, and wetlands because these systems provided food, water, materials, and protection. The biosphere was not an abstract ecological concept. It was the infrastructure of survival. Then settlement changed the relationship. Agriculture allowed people to remain in one place. Forests were cleared. Grasslands were cultivated. Wetlands were drained. Rivers were redirected. The living landscape became something that could be organized. And once land could be organized, it could be engineered. Some of the earliest large-scale human interventions in the biosphere were not buildings at all. They were landscapes. Terraces transformed steep slopes into agricultural infrastructure. Irrigation systems moved water across otherwise unproductive ground. Canals connected rivers to fields. Embankments controlled flooding. Human beings were beginning to construct environments rather than simply occupy them. The boundary between architecture and landscape began to disappear. The ancient world expanded this relationship. Cities depended on territories extending far beyond their walls. Food had to be cultivated somewhere. Timber had to come from forests. Stone had to be quarried. Water had to be captured, transported, and distributed. The city was therefore never an isolated object. It was part of a much larger biological and geological system. Every settlement had an ecological footprint, even when its inhabitants had no language for describing it. Industrialization transformed the scale. Machines allowed landscapes to be altered faster and more extensively than ever before. Forests became timber. Rivers became power. Soils became agricultural production systems. Minerals became construction materials. Nature increasingly became something to be separated, controlled, and optimized. Architecture moved away from the living landscape. Buildings became sealed objects. Cities became artificial territories, and the more successfully we insulated ourselves from environmental conditions, the easier it became to forget how completely dependent we remained upon them. The modern building represents one of humanity's greatest achievements in environmental control. Temperature can be regulated. Air can be filtered. Humidity can be controlled. Light can be produced without the sun. Water can be pumped vertically. Food can arrive from thousands of kilometers away. Inside the building, the external environment can almost disappear. But this independence is partly an illusion. Every mechanically controlled interior requires energy. Every artificial environment depends upon infrastructure outside the building. The sealed building did not eliminate its relationship with the biosphere. It simply moved that relationship elsewhere. The consequences became visible at the scale of the city. Energy consumption increased. Natural habitats fragmented. Urban surfaces replaced vegetation. Rainwater could no longer enter the ground as it once had. Concrete absorbed solar energy and released it back into the atmosphere. The city began creating its own climate, and this created a new architectural problem. If buildings could transform their environments, could they also begin restoring them? The answer began with a simple reversal. Instead of removing nature from architecture, architects began bringing it back. Green roofs were among the simplest expressions of this idea. A roof could become more than a surface protecting a building. It could hold soil, capture rainfall, provide habitat, reduce heat, support vegetation. A building could begin performing some of the functions of the landscape it had replaced. The same principle moved vertically. Facades became growing surfaces. Balconies became gardens. Courtyards became miniature ecosystems. Trees were incorporated into buildings not merely as decoration, but as components of the environmental strategy. The important shift was conceptual. Nature was no longer being treated only as scenery. It was becoming infrastructure. Vegetation can provide shade, plants can intercept rainfall, soils can retain water, wetlands can filter pollutants, trees can store carbon, habitats can support biodiversity. Ecological processes that evolved over millions of years can perform functions that conventional infrastructure often attempts to reproduce mechanically. This does not mean that planting trees can replace every engineered system. It means architecture can begin to work with processes that already exist. A road does not necessarily need to send every drop of rain into a pipe. A city does not necessarily need to treat every landscape as a sealed surface. Water can be slowed, stored, filtered, absorbed, released gradually. The landscape itself can become part of the infrastructure, and once this principle is accepted, the possibilities become much larger. The next stage is not simply to put more plants on buildings. It is to reconsider the city itself as an ecological system. Cities already contain enormous flows of water, energy, heat, nutrients, materials, and biological activity. The question is whether those flows can be designed more intelligently. Rooftops can produce food. Vacant land can become habitat. Stormwater can be captured locally. Organic waste can return nutrients to soils. Buildings can provide nesting sites for birds and insects. Parks can become connected ecological corridors rather than isolated islands. Even streets can become part of a larger living network. This changes the way urban infrastructure is understood. A conventional system is often designed around a single function. A road moves vehicles. A drain removes water. A wall separates one environment from another. An ecological system can perform several functions simultaneously. A planted corridor can provide shade, habitat, pedestrian movement, and stormwater management. A wetland can store water, support biodiversity, and improve water quality. A productive landscape can provide food while also cooling the surrounding environment. The city begins to operate less like a machine and more like a network of interacting systems. The future may take this relationship further. Architecture is already beginning to explore materials derived from biological processes. Timber can replace more carbon-intensive structural materials in some applications. Mycelium can be cultivated into lightweight products. Algae can be used in experimental building systems, Living materials are being researched for their ability to grow, regenerate, or respond to environmental conditions. These technologies remain at different stages of development. Some are commercially established, others are experimental. But together, they suggest a fundamental change in the definition of construction. For thousands of years, building meant extracting material from the landscape and assembling it into permanent form. The emerging model is different. Some materials may be cultivated. Some may regenerate. Some may perform environmental functions while they are part of a building. The building may no longer be something placed upon the biosphere. It may become part of it. The history of human construction can be read as a gradual expansion of control. We learned to shelter from the environment, then to reshape it, then to engineer it. Now we are beginning to ask whether the built environment can participate in the systems that sustain it. That does not mean returning to a world before cities, nor does it mean covering every building in vegetation. The challenge is more fundamental. It is to understand that every building occupies a living system. Every road crosses a watershed. Every foundation occupies geological material. Every city depends on ecosystems beyond its boundaries, and every structure changes the flows of energy, water, carbon, and life around it. The future of architecture may therefore depend less on how completely we can separate ourselves from nature, and more on how intelligently we can become part of it. The biosphere was the first environment humanity inhabited. For most of our history, we treated it as something to overcome. The next phase may be different. We may learn to build within living systems without destroying the systems that make building possible. Not architecture against nature, not architecture beside nature, but architecture as part of the landscape itself. Because the future of the built world will ultimately be determined by the world we inhabit, the living world, the biosphere.